Let's look at another one here from page 352, exercise 1. We'll look at D. In D, they just gave us a constant here for L. They didn't mess around like they did in the last one here, giving us variables. So in this one, we should be able to determine the sum without having to resort to displaying it as a variable. So 5 plus 9 plus 13, whatever, to 97. So we don't know what n is. Let's write this out here. This is 1D. 5 plus 9 plus 13 plus dot 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 plus 97. We don't know what n is, but we do know the first term, we do know the last term, we do know d, so we do know quite a lot. Let's see if we can use this formula here, which is n squared, or sorry, n over 2, we don't know what that is, times a, which is 5, plus l, which is 97, and that equals n times 5 plus 97, 102 over 2, which equals 51n. So the number of terms times 51 will give us the sum. Can we figure out the number of terms? Well, we do know a formula that we saw before, a plus n minus 1d. We know that formula, so can we solve for n using this formula? We sure can. We know that 97, the last term, equals the first term plus n minus 1, we don't know what n is, times d. And we're adding 4 each time, as we can see, so that's times 4. So 97 equals 5 plus 4n minus 4. 97 equals 1 plus 4n. Subtract 1 from both sides. 96 equals 4n, and therefore equals 24. And if 24 is n, then the sum equals 51 times 24, which is 24, 0, 22, 10, 11, 12, 12, 24. And there's our answer. And as you can see, before I pass on this, we've used two formulas. We used the one that we knew before, and that's because we knew A, we knew D, we knew Tn, which is 97, also known as L, and that's what we used to derive n once we determined that the sum was 51n.